Hi, I'm Ching, and this is the FST 4300 research method, the proposal, the PowerPoint. And my topic is the feasibility and challenge of solar energy praying for the continuous flight. And so, my research question is, how feasible and challenging is a solar energy praying for the continuous flight? And before we move on, let me talk about the solar energy. It is one of the most clean, renewable energy source, which can power many different applications and devices. And the sun wave will bathe the earth with like around 885 million terawatt hours annually. And at the same time, I have read a news article about the solar energy plane, which are the aircraft that use solar energy and solar panels to convert sunlight into electricity and power the propulsion system. And it can fly for long distance without refueling or emitting greenhouse gases, which can fulfill the environmental perspective of a company. And one of the most significant program is the Salvia, which had stayed in the air for 25 days and without landing or fueling. And this make me think of the possibility of continuous flight of solar plane energy plane, because the plane will keep staying on the ground. If there is sunlight, it can charge the plane automatically. If there's no sunlight, the power battery can save the energy and it can still fly. And so a plane that do not need to refuel will appear. And so I make this research proposal. And is it possible for the solar energy planes to fly in the sky continuously? If yes, many challenges and limitations must be overcome. And this research proposal aims to investigate the feasibility and the challenges of developing a solar energy plane that can fly continuously. And the main research question is, how can solar plane achieve continuous flight on Earth? And what would be the challenge involved? And as I mentioned about the Sylvia Airbus, it had maintained many achievement, like the highest altitude reached by a solar energy plane and etc. And as this as the continuous flight is not yet here, so I do not have any literature review to share. But there are four components to maybe really let the plane to continuously fly on the sky. And first is the solar panel. And the solar panel is um, the panels that are hide under the aircraft wing, and so it can convert the solar energy into electricity and to give it to the plane. And however, the weight of the solar panel will affect the power output, and the solar energy planes sorry lift to drag radio. And so, as a result, a flexible material can be used in order to reduce the weight. And secondly, for the batteries, it is a device that store excess electricity and and to generate energy to the ignition system. And so for the capacity, it may affect the energy density and the charging time at the airport and cause inconvenience for passengers, as they may need to wait for a long time if the battery is need to charge for a long period of time. So using a high performance battery will be a very good idea. For the propulsion system, the noise problem will be the most challenging part, because for the normal engine, it had many things, many technologies to reduce the noise level. However, as the solar energy airplane, it will use a different kind of engine, maybe, and so it may be a big difference, and it may become noisy, and so also it is costly in maintenance if a new noise cancelling technology only for the solar plane is developed. Finally, for the control system, it is the control system for connecting the ground handling and the pilot, and the system's stability and reliability will be a problem as the mechanism are not yet well developed, and maybe when a pilot need to call for a mayday, the system suddenly broke down and it will be a very big problem. So the fault tolerance can be used to detect and recover errors in the plane. And for the methodology, we can collect and analyze data on the performance of the existing solar energy plane and to find ways to improve them. And I will find information from the internet and from books. And also interviews will be done. Question will be asked, and the questionnaire will be in the proposal Word document. And the interviewees will mainly be the engineers from the aviation industry. And the second one may be the model design and simulation. If in year 4, I will use this topic, and I may ask the engineers from the HKAA for help, because my father worked in HKAA and he got some friends that are interested in this topic, and I may ask them for help if I really need to do this research question. Expected outcome. Continuous flight is possible, but there are many technical challenges and limitations that will affect the feasibility of the continuous flight, and it will need to be faced. And for the timeline, it will be a year. So literature review and data collection 3 months, data analysis 4 months, and make the survey question and ask for the engineers, and it will take 3 months. And finally, the report and presentation 2 months, and altogether 1 year. Finally, for the budget one, there are 20,000 in total, and so 5,000 will be buying articles and books, and maybe buying the copyrights from the internet, etc. And 10,000 will be to buying the solar energy related materials for experience, 3,000 for the printing data and survey questions, and finally 2,000 for the coupon provided to the interviewees after they finish the interview. And that's all for my presentation.